In this session, we will discuss about switch port security. So it is basically a port level security. So purpose of switch port security is to secure layer 2 access as well as to enhance LAN security. So how to enable port security on a particular port? You need to go to a particular interface. Example over here is interface F0/1. And you need to write switch port security. By this command, basically enable port security on this interface. By default, port security is disabled on switches. So to check that port security is enabled or not, or to check that status, you can give this command show port security interface F0/1. Next, there is another facility is also available, like maximum MAC address that is allowed on that port. By default, maximum MAC address allowed on a particular port is 1. So if you want to change that by default, you can give this command switch port security maximum. I had taken example over here is 2, you can take 4 or n number. Now MAC address learning. MAC address learned by switch in two ways. First one, we can configure it statically, and another way is dynamically. So if you want to give statically, then you can use this command switch port security MAC address, and you need to specify MAC address after that. And if you want to configure it dynamically, you can use this command switch port security MAC address sticky. So whenever that particular node attached to that port, at that time that MAC address is registered. Next is if the security is violated, then what happened with that particular port? So here there are three options, that is protect, restrict and shut down. So if you are writing protect, then it basically work with the sticky option, and if violation occur, it's only allowed the registered MAC address. If that MAC address is not registered over there, at that time it will drop that frame and it never generate alert. But if it is restrict, then it drop that MAC address frame, that is a violated MAC address, but it also generate alert. In the third case, if it is shut down, then it generate violation message or logs, as well as it basically make port disable. So how to configure this thing? So you can use this command, that is switch port security violation protect. Instead of protect, you can also write restrict and shut down. As per your requirement, you can write. Now we will discuss practical of this switch port security. Here I had considered this topology. In between this is a switch, and this two computers are connected with this switch. So we will configure switch port security on this particular switch. So if you want to configure that, you need to go to interface F0/2 switch port security maximum 2. So here the maximum 2 MAC addresses are allowed to register, as well as switch port security MAC addresses sticky. Here MAC address is learned by dynamic method. Next thing is if violation occur, then what happened? Switch port security violation protect. So here we had written switch port security violation protect, and it will never generate locks. Now we will go on F0/3. So here I had taken in the violation is shut down, MAC address sticky, and maximum allowed MAC address are 4. So this is our configuration of switch port security. So we will configure Gre tunnel, and we are using this particular topology to configure Gre. So here in configuration, if we are assuming that router 0 is in another city and router 1 is in another city, and between is the ISP, then how we will configure Gre tunnel? So configuration command is interface tunnel 1. We are creating a tunnel 1 interface. Before that you have to give actual IP to a particular interface, like here an IP address given over here is IP address is 172.16.1.1, that is 255.255.250, and tunnel source is this. Here we need to specify the tunnel source and tunnel destination. So that's why from where tunnel is starting and what's the destination of tunnel we need to specify. So this is our configuration, and we will configure this particular topology. So here I had considered for Gre tunnel this topology. Network over here is 192.168.10.0, where network over here is 192.168.20.0, as well as there is a serial link in between this and this router. I had already configured IP addresses over here and here. Right now we are just configuring tunnel. So you have to write interface tunnel and tunnel number. So as we can see over here, that is interface tunnel 1 change state on. Now on this tunnel you have to give IP address. So here I am giving it is same as a normal IP address, but it is tunnel IP address, and tunnel source. What is the source of tunnel? So here we will write the tunnel source is our IP address, or we can write our interface, that is S0/0/0, and tunnel destination is the IP address of serial interface, that is our neighbor, and exit. Now we are just going over here on the another router, and we will do that same thing, tunnel 1, and on that interface we have to give IP address is 172.168.10.2. So after that, tunnel source is our interface, and tunnel destination is 1.1.1.1. So here we had make, that is Gre tunnel. Now if we want to check that tunnel, so show interface tunnel 1. So here we can see over here this tunnel is up, line protocol is up, it is a hardware tunnel, address is this one, as well as each and everything it is mentioned. Tunnel source is 2.2.2. That is serial and destination is 1.1.1. Tunnel protocol is GRE IP, and information is over here. So this tunnel is created right now. So as we can check over here, same thing. Show interface, tunnel 1. So this tunnel is also up, it is connected. So now if we are sending any data, it just go through this tunnel and it will reach to another interface. So this is our GRE tunnel configuration. Next we will discuss about GRE tunnel. GRE tunnel is generic routing encapsulation. It's a tunneling protocol developed by Cisco. This protocol encapsulates large number of network layer protocols like IPv4, IPv6, ICMP and ARP. So when this concept was introduced, it is introduced by RFC 2784. And basically original packets are encapsulated by additional header including IP header. So it's basically this tunnel is created by two routers by matching configuration setting. If configuration settings are not same, GRE tunnel will never form. So to form GRE tunnel, the duplex should be same, the speed should be same, the MTU size should be same. So all these parameters should be same. Now passenger or encapsulated protocol may be IPv4 or IPv6. So it supports both the IPv4 and IPv6. And the carrier encapsulated protocol is GRE. Now characteristic of it is a stateless and no flow control is over here, and it's not providing strong security encryption. So that's why IPsec is also used with GRE to provide security.